My dear students, let me welcome you all to a new edition of physics. In this edition, we'll try to solve some problems. The problems will be of gradual difficulty. Hopefully, you will find them interesting and useful to you. So let's get started. First problem. In front of you, we've got a circuit, very simple one. It consists of a battery, 6-volt battery. Internal resistance of the battery is equal to 0. And it is connected in parallel to two resistors, 3 ohm resistor, 2 ohm resistor. And it is required to determine, yes, we want the current through the 3 ohm resistor, I1, and we want I2, the current through the 2 ohm, and of course the total current denoted by I. Okay, we don't have any series resistor, and internal resistance of the cell is equal to 0, so V battery is the potential across the parallel group. Let me say it again. 6 volt is the potential across the 3 ohm, and also it is the potential across the 2 ohm resistor. Why? Because internal resistance is equal to 0 and we don't have any other resistors. Okay, so it is so simple problem. Current intensity through the 3 ohm resistor, it is equal, yes, V over R, 6 over 3, it is 2 amperes. And we'll do the same with the other resistor. So I2 equals 6 over 2, it is 3 amperes. Total current, of course, will be equal to, yes, 3 plus 2, it will be 5. I1 plus I2, it is 2 plus 3, it is 5 amperes. This was about the first problem, and it was so easy. It's all easy for you. Okay, the problems are of gradual difficulty. So let's see. Okay, we've got another circuit here, consists of V battery. We don't know EMF of the cell, we don't know V battery, the value of V battery, but it has got an internal resistance. Internal resistance equals 1 ohm, and we've got two resistors connected in parallel, 2 ohm and 1 ohm. And the current passing through the 1 ohm resistor is 2 amperes. Here we've got current and resistance, so we can determine potential difference across the 1 ohm resistor, and of course it is the same across the 2 ohm resistor. Okay, what about the problem? We want you to find EMF of the cell. Calculate V battery, EMF of the cell. Okay, as I said, potential difference across the 1 ohm resistance, it is equal potential difference, product of resistance and current. So it is 2 times 1, it is 2 volt. And what about the potential difference across the 2 ohm? It is the same since they are connected in parallel. So it is 2 volts. We managed to obtain the potential difference. It's all easy to determine the current. So the current through the 2 ohm resistor, it is the voltage, which was equal to over the value of the resistance, 2 over 2, it is 1 ampere. So we managed to obtain the current through the 2 ohm, and we've got the current through the 1 ohm, so we can obtain the current through the battery, the main current. It's all easy, of course. Total current is equal to 1 plus 2, it is 3 amperes. And how to determine the battery? EMF equals V external plus V internal. Okay, so equals V external plus V internal is the product of the current times internal resistance. So it is equal to, yes, external voltage is equal to 2. Current 3 times 1. So it is, yes, 5 volts. Another problem. Here we've got a circuit that consists of 4-volt battery of internal resistance 0.5, and we've got a parallel combination consisting of 8 ohm another 8 ohm and 4 connected in series to 1.5 ohm resistor. Okay, we want you to determine, to find the value of I1, I2, I3 and the total current. I1 is the current through the 8 ohm resistor, I2 is the current through the 8 resistor, also I3 is the current through the 4 ohm, and total current. Okay, since 1 over R equivalent, we've got 3 resistors connected in parallel. So the formula I used here, yes, 1 over R equivalent equals 1 over 8 plus 1 over 8 plus 1 over 4. It will be equal to 1 over 2. So equivalent resistance is equal to 2 ohms, of course. Equivalent resistance of the 3 resistors, 8, 8, 4, is equal to 2 ohms. We managed to obtain the equivalent resistance of the parallel group. And it is connected in series to 1.5 and the internal resistance 0.5. So total resistance equals 2 plus 1.5 plus 0.5. So it is equal to 4 ohm. We managed to obtain total resistance. We've got V battery, so it's all easy to calculate the current using Ohm's law of closed circuit. The current, main current, we call it the current through the battery, denoted by I. It is equal to V battery over R equivalent of the whole circuit. It includes external and internal resistance. So it is equal to V battery 4 over the, yes, total resistance 4, so it is 1 ampere. Potential difference across the parallel combination equals, yes, current times R equivalent of the parallel combination. It is equal 1 times R equivalent, yes, was 2, so it is 2 volts. I1, yes, it's all easy for you. It is obtained, okay, by using the formula voltage over resistance. Voltage, we managed to obtain it right now. It was 2 over resistance. It is 8. 2 over 8, it is 1 over 4 ampere. The current through the other 8 ohm resistor, of course it will be 2 over 8, it is 1 over 4 ampere. And I3 equals, yes, 2 over 4, it is half amperes. Another circuit, here we've got V battery, yes, 10.5 volt battery of internal resistance 0.2, and we've got parallel group. One branch of the parallel group consists of 2 resistors connected in series, 4 ohm and 2 ohm connected in series, and they will give, of course, a resistance of 6, which is connected in parallel to 3, and the group, the parallel combination, is connected in series to 1.3 ohm, and of course we've got an internal resistance 0.2. Okay, we want you to find the current through the 2 ohm resistance, and that through the 3 ohm resistance. Your attention please. The current through the 2 ohm resistor is the current through the 6 ohm branch. They are connected in series. Okay, so 2 and 4 is considered as just one resistor, a resistor of 6 ohm. Okay, so let's calculate the equivalent resistance. Okay, R equivalent of 4 and 2, they are connected in series, so it is 4 plus 2, yes, it is 6 ohm. R equivalent of 6 ohm, the branch of 6 ohms, which is connected to 3 ohm in parallel, product over the sum, so 6 times 3 over 6 plus 3, it is 2 ohms. Okay, so the parallel group, yes, has an equivalent resistance of 2 ohms, and it is connected in series to 1.3. So R equivalent of the whole circuit, including the internal resistance, equals 2 plus 1.3 plus 0.2. It is 3.5 ohm. We managed to obtain the total resistance of the circuit, including the internal one, and we've got EMF of the battery, V battery, so we can use Ohm's law of closed circuit to determine the current through the battery. So the current through the battery I equals 10.5 over 3.5, it is 3 amperes. Potential difference across the parallel combination. Why we want to determine, to find potential difference across the parallel group so as to calculate the current through each branch. Potential difference is divided by the resistance of each branch to give the current through it. Okay, potential difference equals, yes, resistance times current. Okay, 3 times 2, it is 6 volt. Now, the current through the 2 ohm, it is 6 over 2, of course. No, it is 6 over 6. Why? Because 2 and 4 just form one resistor of 6 ohm. Okay, remember this because this is very important. It is 1 ampere. And what about the current through the 3 ohm resistor, 3 ohm branch? It's so easy. It is 6 over 3. It is 2 amperes. Another circuit, another problem. We've got here, the circuit consists of 18 volt battery of internal resistance 1 ohm. We've got two parallel combinations connected to each other in series. First group consists of 4, 4 and 2. Second consists of two resistors connected in parallel 6 and 12. Internal resistance is equal to internal resistance of the battery equals 1 ohm. As I said, the problems are of, yes, gradual difficulty, of increasing difficulty, okay? We are increasing the difficulty of the problems gradually, okay? And now we want you to find the current through each resistors, okay? We'll try to determine the equivalent resistance of the parallel combination 4, 4 and 2. 1 over R equivalent of 4, 4, 2, it is equal to 1 over 4 plus 1 over 4 plus 1 over 2, it is 1 over 1, it is 1. So R equivalent equals R equivalent of 4, 4, 2, which are connected in parallel, is equal to 1. Okay. And what about the other parallel group, which consists of 6 and 12? Product, yes, times product over the sum. 6 times 12 over 6 plus 12, it is 4 ohms. Okay, and now R equivalent of the whole circuit can be calculated. R equivalent of the whole circuit includes the internal resistance. So 1 plus 1 plus 4. Okay, it is 6 ohms. And what about the current through the battery? Ohm's law of closed circuit should be used. It is V battery, which is equal to 18 over R equivalent of the whole circuit 6. It is 3 amperes. And now we need to determine potential difference across each parallel combination. Across the first combination, across AB, okay, it is, yes, potential difference equals resistance times current. It is 3 times 1, 3 volts. And once again, potential difference across the second parallel group, across BC, it is 3 times 4, it is 12 volts. Since we managed to obtain the potential difference, it's all easy. We can calculate the current through each resistor. I1 equals 3 over 4, I2 equals 3 over 4, 3 is the potential, 4 is the value of the resistance. I3 equals 3 over 2 amperes. This was about the first parallel group. And I4 equals 12 over 6. It is 2 amperes. This is about the second parallel. And 12 over 12, it is 1 ampere. Yes, another problem. Here it is a little bit more difficult. Here we've got a battery. Once again, it is 6-volt battery of internal resistance, negligible internal resistance equals 0. We've got a resistance of 4 ohm, yes, and a parallel combination that consists of 18 ohm and 9 ohm. They are connected in parallel. And we've got 2 branches, one branch of 24 ohm, the other is, yes, of 12 ohm. 7 and 5 are connected in series. 12 and 24 are connected in parallel. Okay, and now your attention, you focus on 2 points here, point A and point B. What about point A and B? Yes, these 2 points, when we calculate the potential between these 2 points, we calculate the potential across the parallel group, which consists of 24 and 12. Okay, now find I1 and I2. Once again, R equivalent of the whole circuit. Okay, 12 and 24 are connected in parallel, product over the sum. Also, we've got 18 and 9, product over the sum, plus 4. So, in one shot, we managed to obtain R equivalent of the whole circuit. It is 18 ohm. And now current through the battery by using Ohm's law of closed circuit. It is, yes, 12 plus 6 over 18. It is 1 ampere. Okay. Potential difference, okay, across AB equals 1 times R equivalent of the 2 branches, 24 ohm branch and 12, yes, ohm branch. So it is 1 times 8. It is 8 volt. Current I1 equals 8 over 24. I2 equals the potential 8 over 12. Okay. Another type of questions, it is verbal questions. We've got 3 resistances, 18, 9, and 3, are connected to an electric source, supply. Your attention, please. The way they are connected together is not mentioned. Let me say it again. 3 resistances, okay, 18, 9, and 3, are connected to an electric supply, DC supply, of negligible internal resistance. Currents of 0.1, 0.2, 0.3 pass through them respectively. Find EMF of the cell. Find EMF of the supply. Potential difference across the 18 ohm. Why we want to calculate potential difference? Resistance and current are mentioned, so it's all easy to calculate potential. And when we calculate potential, the resistors which have the same potential are connected in parallel. So it will give us a picture to the way the resistors are connected. So potential difference across the 18, it is the product of current and resistance. It is 18 times 0.1, it is 1.8 volts. We'll do the same concerning the 2 other resistors across the 9 ohm resistance. It is 9 times 0.2, it is 1.8 volt. They've got the same volt, so they must be connected in parallel. And what about the potential difference across the 3? It is 3 times 0.3, it is 0.9. Okay, so it must be connected in series to the previous parallel group. Okay, so in front of you is the possible way of connecting the 3 resistors. 18 ohm and 9 are connected in parallel because they've got the same potential, and both of them is connected in series to 3. And there is something you should do so as to check that your answer is correct. Okay, the current passing through the series resistor should be equal to the sum of the two currents passing through the parallel group. Okay, the current passing through the 3 ohm resistor equals 0.3, and it is equal to 0.1 plus 0.2. So I'm quite sure it is correct. Now I'll determine our equivalent of the circuit. Yes, 2 connected in parallel, product over the sum, plus 3. It is 9 ohm, and it is multiplied by the current so as to obtain the potential of the battery, V battery, EMF of the cell. So it is 0.3 times 9. It is 2.7 volt. Another problem, a current of 0.2 ampere passes through a uniform wire. Okay, when a potential difference of 3.6 volt is applied across its ends. So we've got a uniform wire. What does it mean, uniform wire? It means it has got, yes, uniform cross-sectional area. The area is constant, so resistance will be proportional to its length. Okay, when applying a potential difference of 3.6 volts, a current of 0.2 passes. So we've got enough data to calculate the resistance of the whole wire. A current of 0.2 ampere passes through a uniform wire when a potential difference of 3.6 volt is applied across its ends. Okay, the wire is shaped into a rectangle ABCD such that the length of AB is twice that of BC. Find the equivalent resistance of the wire. If an electric supply is connected, yes, across A and B, points A and B. If an electric supply is connected across A and C. Okay. First of all, yes, we need to calculate the resistance of the wire. Potential over current. It is 3.6 over 0.2. It is 18 ohm. Okay, the wire is uniform, so resistance is proportional to its length. So resistance of AB equals twice the resistance of the portion BC. Why? Because length of AB is twice that of BC, mentioned in the problem. So also RCB equals RDA. So we can say 2RAB plus 2RBC equals 18. And of course, resistance of portion AB plus resistance of portion BC equals 9. Okay, substituting for resistance AB, it is equal to 2 resistance BC plus BC equals 9. So we managed to obtain the resistance of the portion RBC. It is 9 over 3, of course. It is 3 ohms. And now resistance of AB equals 6 because it is twice the resistance of BC. Now we managed to obtain the resistance of each branch. Okay, what if the battery is connected across what? AB. When connecting the battery across AB, 3, 6, and 3 will form just one resistor of 12. And this 12 branch is connected in parallel to the 6 ohm branch. They are connected in parallel, product over the sum, 12 times 6 over 12 plus 6. Okay, it is 4 ohms. This was when connecting the battery across A and B. And what when we connect it across, yes, AC? In this case, we've got 2 branches, one of 9, and the other branch will have a resistance of 9 ohms, and they are connected in parallel, so it's all easy. 9 over 2 it is 4.5 ohms. Another important problem in front of you, we've got a table. Okay, we've got, yes, material, wires, material, length, area, and resistivity at 20 Celsius. We've got 3 wires. One made of aluminium. Its length is, yes, 178.57 centimeter. It should be converted into meters. Area 0.001 centimeter squared. It should be converted into meter squared by multiplying it, yes, 10 power negative 4. Resistivity equals 2.8 times 10 power negative 8 ohm meter. This was about aluminum wire. What about the other wire? It made of brass. Length 200 centimeters. Area, same area. And resistivity 8 times 10 to the power of negative 8 ohm meter. And finally, the third wire are made of silver. Length 150 centimeters. Area 0.001, same area. And resistivity 1.6 10 power negative 8 ohm meter. And what about the questions? Which wire had the highest ohmic resistance? 1. Which wire would produce the greatest amount of heat if the wires were connected in series to a DC supply? Which wire would produce the greatest amount of heat if the wires were connected in parallel to a DC supply? Okay, we'll take it one by one. We'll determine the resistance of each wire by using the formula R is equal to rho E L over A. So resistance of the first wire, we've got resistivity, length, and area, so it's all easy. And it is calculated, and it was found 0.5. This is the resistance of the aluminium wire. It was 0.5 ohm. What about the resistance of the brass? Doing the same? In doing so, we found it to, yes, to be equal 1.6. And what about the silver one? Using the same formula, applying the same expression, okay, we managed to obtain the resistance. It is 0.24. Okay, the brass wire had the highest resistance. Okay, when connecting in series, this is very important. Asking about the heat produced is asking about the power. Okay, when connecting in series, what happens? This is very important. Your attention, please. Rate of the heat produced, which is the power, is determined from the relation I squared R. Connecting in series means current is the same, is constant. So heat is proportional to the resistance, is directly proportional to the resistance. The higher the resistance, the greater the amount of heat produced. Okay, so which wire? The wire which has the highest resistance, it is the brass wire. When connecting in parallel, it is the opposite way. Okay, rate of heat produced is given from the expression V squared over R. Why using this formula? Because when connecting in parallel, the voltage is same. It will be quite clear for us that the heat is inversely proportional to the resistance. Okay, the silver wire produces the greatest amount of heat. In this way, we've come to the end of this edition. Until we meet again, my best wishes to you all. Thank you very much.